Hello, my dear friends. Welcome back to your channel of learning mathematics. What are we going to do here today? We are going to do something. But let's see what we did last class. Last class, we talked about, we learned how to differentiate implicit functions. We learned about how to differentiate using trigonometric transformations. We also learned how to differentiate inverse trigonometric functions. In this video today, we are going to be learning how to differentiate exponential and logarithmic functions. So, alright then, welcome back once again to your channel of learning mathematics. If you still haven't subscribed, please subscribe. Please do like the video also. Alright then, I hope all of you are doing well. Shall we begin? Let's begin. This is a very small exercise. This is like a preparation warm-up exercise for the next exercise. That's basically about how to differentiate using or taking the help of logarithmic functions. So that's going to be a big exercise. For that, of course, we are going to be going live. But this small exercise, let's see. But there's nothing much. We have already done this. Okay, derivatives of exponential and logarithmic functions. If you remember, we have already done this formulas in the beginning of derivatives, that is derivative of exponential function e power x, already done. E power x, derivative of log x. Of course, if the base is e, then it's 1 by x. We've also done derivative of a power x, another exponential function, that's a power x. This is very rarely used, a power x into log a. Then another one, that's derivative of log x if the base is e. Remember this formula? If the base is e. If you still remember, you can find out what is the formula for this. Yes? Any guesses? Yes, it was C. These are very rare formulas. I'll just write here. It is 1 by x log a. Alright, so if you haven't noted down, please note down. Take out your pen, book, paper, everything. Get ready. Start writing it down. Sit on the table, not on the roof or on the floor or anywhere. Sit on the tables, on your chair. Take out your book, pen, paper, and let's prepare ourselves for the next small exercise that will be winding it up very soon. 1 by x log a. Done. Of course, we are also going to be needing the main concept, that's the chain rule. Definitely there is partial differentiation is all about that chain rule. Then of course product rule, quotient rule, all that will be used, but we have already learned all those stuffs. So let me not repeat that again. Okay, so let's go straight to the exercise. Exercise 5.4. So shall we begin? The question is, I'm not going to write down. The question is simply differentiate the following functions with respect to x. Number 1, I'm writing y equal to e power x upon sine x. Alright, I'm not going to repeat this again. So let's just rewind ourselves with the quotient. Differentiation of quotient function. So denominator square, denominator into derivative of the numerator minus numerator into derivative of the denominator. So if you have forgotten it, please note it down. We're going to be using this. And of course chain rule, definitely. Okay? No? Chalo. So let's differentiate both sides with respect to x. So differentiating, I'm not writing all those stuffs, you can write down. Differentiating both sides with respect to x. Let's just finish this up. Dy by dx is equal to, using quotient rule, what would be? Square of denominator, then denominator into derivative of the numerator minus numerator into derivative of the denominator. Okay, na? So that will be simply sine square x. Let's do it. Simple questions into e power x minus e power x into cos x. E power x we can take common if you wish. So e power x sin x minus cos x divided by sine square x. Of course, there's one condition. This is dy by dx. You will find one condition that of course x should not be n times of pi, where n belongs to the set of integers. You know why, isn't it? Why? Because we always know denominator should never be 0. So the function sin x will give us 0 or for all values of x equal to n times of pi. That we have already studied in trigonometry. So that's why we'll have this given in the answer also in the NCERT textbook. Simply because the denominator cannot be 0. So simple differentiation only. Chalo, let's finish it up. Next question number 2. How are you doing, all of you? It's been a long time. Actually, I was busy with some works at home, so I couldn't really upload for the past 1 week or so. But yes, I'm back again to do mathematics for you and learn from you, from me, give and take. Alright, differentiating both sides with respect to x, I'm going to write this, e power sin inverse x. I hope all of you are doing well. Please do stay safe, wear your mask every time, stay at home as much as possible. So differentiation of what is e power x? Chain rule again. Differentiation of e power x is e power x. But with the concept of chain rule, we have already done enough of chain rule. Okay, so I hope by now you already know. Sin inverse x into derivative of sin inverse x is 1 by root over of 1 minus x squared. You can arrange your answers and write it down. I'm not going to do that because I'm here trying to save some time for you. So that will be e power sin x, sin inverse x, sorry, e power sin inverse x into root over of 1 minus x squared. Of course, here also the answer will be like x belonging to open bracket between minus 1 and 1, because this should not be 0, as well as, that's why it should not be 0, so it will be 0 only for plus 1 and minus 1. And it should be less than between these values only, because otherwise it will give us a negative value. That's again imaginary number, so that is also not allowed, especially for a root. That's why all these conditions are given to you in the answers. So I hope you understand by that. Okay. Alright, number 3. Simple, isn't it? Good. You must be wondering, such a simple exercise, how did it come here? Even I don't know, but that's why. Warm up for the next exercise. So now dy by dx, another simple question again. Derivative of e power x cube. So again, derivative of e power x is e power x, but we know we have to proceed with chain rule. That's x cube. So that's, I'm going to write derivative of x cube is 3x squared. I'm directly writing by arranging. So 3x squared into e power x cube. Simple question, simple question. Ho gaya? Chalo, next one. Number 4. So y equal to sine of tan inverse e power minus x. Tan inverse e power minus x. So, alright, let me just write down, not a big deal here. Tan inverse e power minus x. So what is differentiation of sin x? Cos x. Cos of tan inverse e power minus x. We will have to proceed with derivatives of tan inverse e power minus x. So we have how many functions here? According to that only we will proceed, isn't it? For the chain rule, we have how many functions here? 1 minus x is also a new function, isn't it? When we talk of chain rule, 1, 2, 3, 4. We have actually 4 functions. So let's differentiate. So that's going to be cos of tan inverse e power minus x. Cos of tan inverse e power minus x. Okay, what is the formula for tan inverse x? Tan inverse x is 1 by 1 plus x squared. Then differentiation of e power minus x. Okay? I'm rubbing the upper part, done, no? So dy by dx would be cos of tan inverse e power minus x divided by 1 plus e power minus 2x, I guess you can understand, into what is derivative of e power x? E power minus x only, but again we'll have to continue with our differentiation of minus x. Chain rule concept. So that's going to be cos of tan inverse e power minus x into e power minus x into minus 1. Therefore, you can understand that 1 by e power minus 2x. Oh yeah. Of course, you can arrange if you wish. Chalo, you can arrange. You can write like minus of e power minus x cos of tan inverse e power minus x upon 1 plus e power minus 2x. Done? Alright. Move on to the next question. Number 5, I suppose. Y equal to, what is the function there? Number 5. Log of cos ex. Log of cos e power x. So again, they're differentiating both sides with respect to x. I'm going to do it directly now. What is differentiation of log x? Log x is 1 by x. 1 by x. But we know chain rule, so that's going to be cos of e power x. So that's going to be 1 by cos of e power x into, what is cos of x minus sin x into derivative of e power x. Derivative of log cos x is 1 by x. So differentiation of again x, that is cos x. What is differentiation of cos x? Cos x is minus sin x. So this is not x, concept of chain rule, again derivative of e power x. So that's going to be minus of sine of e power x upon cos of e power x into, of course, e power x dy upon dx derivative. So that can also be written as minus of e power x sine theta by cos theta, both angles same, tan theta. Okay. Alright, let's move on to the next question, number 6. E power x plus e power x square plus dot 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 plus e power x power 5. Okay, what do you mean by this question? Okay, it's simple, they were just lazy. So let us not be lazy, let's write down e power x dot 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 means e power x cube plus e power x power 4 plus e power x power 5. Simple meaning is that only, if you fully expand. So now differentiating both sides with respect to x, differentiation of e power x is e power x, differentiation of, I'm going to do it directly, okay? Chain rule. Do I have to do it all in detail? I think it's okay, right? Now differentiation of e power x square is of course e power x square into derivative of x square. Now, is it okay? I guess. Yeah, you guys also. Chalo. Derivative of e power x plus derivative of e power x square plus derivative of e power x cube plus derivative of e power x power 4 plus. I hope you are learning from this channel of mathematics. Please do let me know in the comment section below if there's any particular topic which you wish me to do. Do let me know also. And yes, of course, after this I will be definitely making a special video on logarithm because that's really going to be needed for us, so that a few concepts regarding the next chapter will be also learned. So e power x plus derivative of e power x square is x square, differentiation of x square plus same e power x cube derivative of x cube plus e power x power 4 derivative of x power 4 plus plus e power x power 5 derivative of x power 5. So e power x dy by dx, I'm just going to write here directly, plus derivative of x square is, we know, I've already given you the shortcut. I'm going to give you some tips. Very soon I'll be bringing out a video on some tips, a very short video on some tips on how to differentiate very quickly. Please do watch that also. Differentiation of 3x x cube is 3x square e power x cube, plus derivative of x power 4, 4x cube into e power x power 4, and this is 5x power 4 e power x power 5. I think that should do. E power x plus 2x e power x square plus 3x square e power x cube plus 4x cube e power x 4, 5x4 e power x 5. Okay. Alright, let's move on to the next question, that is number 7. If you haven't finished, pause the video there, and then write down. I hope you're learning. Please do manage your time well. Next one is root over of e power root over of x. Of course, root x should be greater than 0. Yeah, otherwise this would turn out to be a complex number, imaginary number. So square root of e power root over of x. So differentiating. What did I tell you? Remember, of course, I'll be giving you some tips, as I said, on some videos on how to do some basic differentiation very quickly. But if you remember in some, I think, I don't know in which video was it, in some video I've told you just write root over of x is as 2 power root x. So this will be 1 by 2 power root x. The only problem is this is not x, isn't it? This is e power root x. So this one again you'll have to take out and differentiate. So that's going to be 1 by 2 root over of e power root over of x into e power root x is e power root x, but again chain rule proceeds. See, your main problem would be the chain rule, okay? So don't mess up there. Of course, it will depend, as I always say, maths, nobody's born with maths. It's an art which you'll have to master it, with rigorous practice. Okay, practice. You know what is the meaning of practice, no? And of course, you can arrange this. E power root x divided by 2 to the 4. Root, I can bring it under one common umbrella. X into e power root x. So yeah, of course, x should be greater than 0. X into e power root x. Of course, yeah, if you wish, you can write on a condition also. It doesn't really matter because you're not doing some research here. So it's good if you write on the conditions. If you don't, also no problem. Yeah, for competitive exams and all this might mean something. This concept will be required, of course. Alright, almost finishing up. See how quickly? Number 8. Log of log x. Of course, x should be greater than 1, otherwise it will not be defined. So dy upon dx. What is derivative of log x? 1 by x. What is x? Log x. Wow. Into derivative of log x. So 1 by log x into what is derivative of log x? 1 by x. Bus. So that's 1 by x log x. Dy by dx. Of course, x should be greater than 1. It's already given in the question also. Okay? Chalo. Number 9. Simple questions. What is 9? Cos x by log x. Condition? Chalo, x greater than 0. I'll use quotient rule. Log x whole square. Log x. This is like going back into time and to class 11 and then again doing differentiation. Especially this question, no concept of chain rule also. There's not much to discuss also in this question, very simple question. So this will be log x whole square, taking a common LCM, x. I'll just write this a little bit smaller, log x whole square. So this is minus of, if you take the LCM, this is 1, so cos x by x, so x sin x log x minus cos x. So dy by dx, taking minus common, we'll have x sin x log x plus cos x divided by x log x whole square. Of course, x should be greater than 0, strictly greater than 0, already given in the question. So minus of x sin x log x plus cos x divided by x log x square. As mentioned, x strictly greater than 0. Cannot be less than 0 also, because log is not defined for negative values. And cannot be 0 because then the denominator would become 0. That is not possible in mathematics. And finally, the last question of the day, that is almost done, number 10. The function is cos of log x plus ex. Log x plus ex, of course, x greater than 0 as usual. So differentiating both sides with respect to x, what is derivative of cos x? Derivative of cos x is minus sin x. Minus sin x. Then chain rule again. Derivative of log x plus e power x. So minus of sin log x plus e power x. What is derivative of log x? Well, nobody knows. 1 by x e power x. Oh yeah, that's all. Nothing much to be written there. So you can leave it there also, no problem. Of course, yes, if you wish to write, you can write x greater than 0. So that was the exercise 5.4. So nothing much here with this exercise. So please make sure that you write down everything. Sometimes it might be just for 2 marks and all. So yeah, important as I said for the next exercise, which is going to be a big exercise. We will learn how to differentiate using logarithmic functions. Alright, so please follow the classes regularly, watch the videos properly, full length, and yes, that's it for today, folks. I will see you tomorrow, next class. Alright then, take care all of you, stay safe.